Hello. I'll be doing some stuff in a second. Okay, hey, how's it going, guys? Yeah, I teach at a school in Baltimore. I'm actually going to be going back. Like, this is probably my last year teaching. I'm going back to get a master's in the fall, but yeah, I've been teaching computer science for about 5 years now. Yeah, go ahead and tell me what you think. What would you like me to go over? I don't have anything set to go over necessarily right now. I mean, I can, but yeah, just give me something that you'd like to review, and I can review it with you. Sorting and searching? Yeah, I can do that. All right. I'll do. Yeah, so the sorting questions, you never have to actually write the sorting algorithm out. Typically, what it is they'll give you an insertion sort or a selection sort or something like that, and then they'll ask you to fill in the details as they come along. So they'll say something like, let me see if I can find one. But I'm going to go over searches because the searches are just really pretty easy to explain, I think. So the questions they might ask are things like this. So it's like they'll give you some code. This is actually one of this would be one of the harder ones, but still reasonable. This is like I said, this is actually a fairly difficult one. And what this says is after mystery happens, what is the what is this going to look like? Or actually, I'm sorry. This isn't actually even a. I'm sorry. This is a searching question. So this is giving you a binary search essentially. So you don't have to know how to write it necessarily, but this is what a binary search looks like in the sense of like you're having the data set as you go along, and then you pick a midpoint, and then you can just decide, okay, I should go further or along, or I should go back, or something like that, and then you just eliminate the part of the data set that you don't need. So with a binary search on this, what it's going to do is, Okay, this says s.mystery 043. So it's giving you a high of 0 and a low of, a low of 0 and a high of 4, and then the number 3. So we're looking for the number 3. And what the question asks is, what is printed when the following main method is executed? Or I'll say prior. Prior main method is executed. And the way we can just go ahead and trace through that. So what we can do is we can say, okay, well, we have a low of 0, a high of 4, and a num of 3. Now, I'm not doing this on paper, so otherwise I'd actually take some notes and just to keep track of what the low, high, and num is, but we should be able to just trace through it just by looking at it. So here we're calculating our mid. Mid is going to be 0 plus 4, because that's low plus high divided by 2. So right now mid equals 2, so I'll just take a note of that because it's going to make it easier. If low is greater than high, which it's not, else if our mid, so our mid right now is 5. That's what is indexed at 2. So our mid is not less than the num, which is 3. So 5 is not less than 3. So we go to this else if, which says if our mid is greater than num, which it is, because 5 is indeed greater than 3. In which case we say return mystery, and you keep the same low, but now your high is replaced by your mid minus 1. So now we're actually going to be passing 1 back into the function, and then we're still looking for 3, so that doesn't change. So now we make a call 0, 1, 3. So now what we're going to do is, so we have low is 0, high is 1. So we have 0 plus 1 divided by 2. So our mid's going to be 0 this time, because 0 plus 1 divided by 2, because we're doing integer division, is 1/2. 1/2 when you cut out the decimals is going to, or the fractional component is going to be 0. So the mid's 0 now. So in this case it says if low is greater than high, which it's not. I'll just make a note. So low equals 0, mid equals, or high equals 1. So if low is greater than high, which it's not, if our mid is less than num, which it is, so we're going to return mystery, where we replace the low by mid plus 1, so that's going to be 1 now. And then high is still the same, and then num stays the same. So then we go back into the method. We call it with 1, 1, and then 3. So then we get 1 plus 1 divided by 2, which is 1. And if low is greater than high, it's not. If our mid is less than num, it's not. If our mid is greater than num, it's not. And if return mid. So this is going to return 3. So basically what these are the types of questions that you would see. This isn't actually as hard as I thought it was going to be. It's basically just testing your knowledge of whether you've seen these things before, not necessarily whether or not you know how to write them. To give you an idea, a linear search would look like this. It would just be public static and linear search. So there's linear search and binary search. We actually just went over binary search, which is the harder one. So let's say we're trying to find a particular target, and we're just going to return the index where we find target. So we'll say, oh, and I suppose we need like some sort of data set to search through, so I'll search through an array of ints. So we'll say for, so we'll say int index equals -1. That'll be the index that we're returning. And we can say for int, I'll say target index, because I want to use index down here. So we'll say index while index is less than r.length, index plus, and then if our index equals target, return target index. And down here we'll just put return target index again if we never find it, in which case it's just going to return -1. Really, we don't actually even need to have the target index. We can just return the index when we find it, and then just return -1 down here, but this is fine too. So for the sorting, So yeah, this is pretty much it with the searching problems. They're really not too difficult. So for the sorting algorithms are actually hard, in my opinion at least. I mean, that's something that I definitely had to sit there and like really go through a bunch to really understand them. They're not easy. So let's look at a. So let me find a problem that we can use here. So I need to find some sort questions. Usually there aren't a ton of sort questions. I actually should have the. Let me see. Where can I find some good questions on sorting algorithms? I think I can find them. So I suppose what I can actually do is let me just pull up an algorithm that'll work. So I'll say Java selection sort code. So this is a method that ostensibly sorts in descending order. So the questions that they would ask on the AP, like this is just the full code. I mean, they wouldn't just say like, here's the code. Usually what they would say is something more like this, which is Ann Landy. Is that my name in Hebrew? That's pretty cool. And I guess that's Mora. Cool. So basically the questions they would ask are things like this, where they would say, you know, there's a value not given here, and then there's an expression not given here. And then it'll be one of those questions where they'll say, you know, A, B, C, D, E, and then it'll say like, they'll potentially give you some values, and then they'll give you an expression, and then you just have to choose the right one. So those are the kind of questions that they'll ask. So you will so it's really just like, I mean, I would take some time and just look at the problems and maybe just like read through some problems, you know, or maybe read through a couple of the algorithms. So the ones I would read through are just like selection sort and insertion sort. Those are usually the ones that pop up on the test. I've never seen merge sort on the test, so I wouldn't worry too much about that one, although because that one's actually a lot trickier too, because that is a recursive sort. Iterative sorts, I think, are easier to understand and digest. So what I would do is just like look through some selection sorts and insertion sort, and that's really just something that you can do, you know, by yourself, just reading. But that would be my recommendation. And then besides that, just make sure you can do a linear search and a binary search. For the binary search, I'd actually recommend just like try to write that out yourself. It's what we did over here. Like try to write this entire thing out. Being able to do a binary search is pretty is fairly important. So I would try that. I can't find any good questions on it. I can probably find some later, or I can probably find some, but I don't. not sure exactly where to look for good multiple choices. So does anybody have anything else that they'd like to go over for now while I try to find some? Because I have an idea of where I can find some, but it'll just gonna take me a minute. So just loops. I mean, yeah, we can go over some loop stuff. I can pull up a yeah, we can do that. That's actually a good time. That's a good way to go over loops. So let's go ahead and go through. So to initialize arrays, you want to. Let me try to think of a problem that would be good for this. Give me a second. So I want a problem where we actually have to initialize an array, and I got a good one. So we can go over a. I'll just do this. So when you want to initialize an array, it just looks like this. You say whatever your data type is. I'll actually do this in general. So data type, square brackets, name of array, and then new, and then the data type again. And then inside the brackets, number of elements, and that's it. So that's how you actually initialize the array. Now, if you want to go through the array, let me try to think of some problems that would make sense to just go over. We can do one like, all right. So we'll do this. We'll go through a problem, and we can say something like, this method returns true if matrix contains all even numbers and false otherwise. We can do something like that. No, the Barron's test is generally a lot harder than the actual test, from what I've seen. The Barron's test is kind of silly hard, to the point where it's almost not even like that good of a book. But if you're getting 4s on the Barron's, you should be totally fine for the actual test. I wouldn't worry yourself. I think you'll do fine. Definitely at least a 4, but probably I would think a 5. So if we want to go through and see if everything's even, I'm going to start off just by saying Boolean all even is true. So we start with the assumption that basically the entire array is actually even. And then what we can do is we can say something like, so we'll say, so we're going through a 2-dimensional array here. So we'll say row is 0. Row is less than matrix.length, row plus plus. And then for int col gets 0, while col is less than matrix 0.length, col plus plus. And then all we have to say here is if matrix row col is and to figure out if a number is odd or not, we can just say if mod 2 equals 1. So if you divide by 2 and it's equal to 1, that's just going to be an odd number. Then is all even is false. and then we can just return is all even. The reason I'm showing you this problem is, for one, it just kind of like goes through loops and like iterating through a two-dimensional array, and that's fine. And so, but what I would do is, like, the reason I showed you this is because it's very common for problems like this for people to do something like, I'm going to comment that out. They'll write something like this, which is, they'll say if it's even. Actually, no, that was fine. That was fine. What they'll write is this. They'll put an else statement in there, and they'll say is all even is true. So that is incorrect, and that's going to not get you points, because what it does is it allows is all even to flip back to true. So even if you hit one odd number and then you just hit another even number at some point, and the rest of the numbers, basically what this checks is if the last number of the array is even, then it's going to return true, which is not what you want. So you actually just want to flip it to false. And then return is all even. So a lot of people have asked me about the matrix row dot length, and that would actually be totally fine. Matrix row would be better if we're working with jagged arrays. Jagged arrays meaning that each row doesn't necessarily have the same number of elements in it. So like you can have like a different number of columns for each row. In that case, matrix row dot length is fine. I use matrix zero dot length because I just think it's a little easier to remember, and it's going to be fine for the AP because there are no jagged arrays on the AP. So that's this kind of problem. And let me see what else. I can just go through a couple free response questions. So give me 1 sec to pull some up. I'm going to try to find one that I think is relevant to what you guys are talking about. Just mostly array stuff, which is fine. So let me get the, I'll just do the 2016 ones. Seems fine. So let's look at this one. So this one has you actually write a full class called random string chooser. So it says the random string chooser object is constructed from an array of non-null string values. When the object is first constructed, all of the strings are considered available. The random string chooser class is a getNext method that has the following behavior. A call to getNext returns a randomly chosen string from the available strings in the object. Once a particular string has been returned from a call to getNext, it is no longer available to be returned from subsequent calls to getNext. If no strings are available to be returned, getNext returns none. So this shows you how it works. So basically you have an array of strings called word array, and then you have, wheels on the bus, 4 different strings. Random string chooser schooser gets new random string chooser word array. So you're passing that array into the random string chooser constructor as a parameter. And then it says for int k gets 0. K is less than 6, k plus plus. Schooser, print out schooser.getNext, and then a blank space. So one possible output is shown below. Because schooser has only 4 strings, the string none is printed twice. So if you're printing out 6 things, it's going to be printing out a random word, eliminating 1, printing out a random word, eliminating 1, and then when it doesn't have any more, it just stops. So the question says, write the entire random string chooser class. Your implementation must include an appropriate constructor and any necessary methods.
Any instance variables must be private. The code segment in the example above should have the indicated behavior. Neither the constructor nor any of the methods should alter the parameter passed to the constructor, but your implementations may copy the contents of the array. So let's try this one out. That's not what I was trying to do. Okay. Control C. We can do this. Whatever. Public class random string chooser. And so what we need is, so we definitely need the constructor, and then we need the getNext method. So let's make a note. We're going to have some private instance variables. We're going to have a one parameter constructor, and we're going to have a getNext method. So let's think about how we can do that. So because we're eliminating things, immediately what I think of to use is an array list. I think keeping all the words in an array list makes a lot of sense because we can randomly choose something from the array list and then immediately remove it so that we don't see it later. And then if at any point the size of the array list is 0, then we can just return none at that point. So I'm going to go ahead and make or at least declare an array list of strings called words remaining, and then just leave it at that. So for a one parameter constructor, it's passed an array, so a one-dimensional array of strings. So we're going to say public random string chooser, and then string my words or something like that. So for this one, the constructor isn't as simple as saying this dot my words gets my words or something like that. We actually have to iterate through my words and then place all of those words into words remaining. So in that case, I'm going to, I think I'll actually just use a enhanced for loop here. So I'm going to say string word in my words, and then I'm going to say words remaining dot add word. This seems like a pretty good use of the enhanced for loop. So the enhanced for loop, you can use it to iterate through array lists or arrays, but the only difference is that you can't change anything in there because when you use an enhanced for loop, string word becomes a copy of whatever we're looking at. It doesn't actually become the actual value in memory, it becomes a copy. So enhanced for loops can be used when you're just iterating through something and you just need to get the values, in which case, like this is right now, that's the case. So I'm just going to go ahead and do that. So now when the user constructs random string chooser and pass their one-dimensional array, it's going to say for string word in my words, words remaining dot add word. It's words remaining is now going to have all of those. So we basically just transferred all to an array list, and now so now we're going to have to make the getNext method. So what we can say is we have to have the none case where the array list is empty. So I'm going to do that first. So I'm going to say if words remaining dot size is equal to 0, return none. So that takes care of it if there's nothing left. But now we have to generate the random index, and to do that, I'm going to say int random index gets, and then so if you remember what math.random does, math.random okay, that's enough of that. So, so if you remember what math.random does, it produces a random double between 0 inclusive and 1.0 exclusive. So what we want to do is all we need to do is multiply math.random by words remaining dot size.
So what that does is, so if words remaining is 4, for example, we're going to get a random double between 0 and 4.0. But if we take that, or 4.0 exclusive, so if we do that int and chop off the fractional components, we're going to get 0, 1, 2, or 3. And then what we actually need to do is once we have the random index, we can just say words remaining dot remove random index. And that'll be it. So this should be a good solution to this problem. I don't think I saw anything else that we needed to do. I just saw that we had the constructor and we had to implement the get next method. But this should be enough to get full points on that question. I just used the enhanced for loop because I thought it'd be a good thing to use. Yeah, the AP exam is. So I did forget to return. Thank you. So you actually want to. Yeah. So you actually want to return this. So words remaining dot remove. So dot remove, if you look at your AP quick reference, it actually returns whatever you remove. So if you say return words remaining dot remove random index, you're actually going to not only remove it from the array, but your array list, but you're also going to return that value. AP scorers do not care at all what your variable names are. You can make them whatever you want. In fact, if you make your variable names kind of funny, they'll probably appreciate you a lot more. It's not going to affect the grading, but at least they might laugh. Because it's pretty tedious to grade all that stuff, but yeah, they don't care. So I like to use really descriptive names just because it allows me to not I don't get as lost if I'm using descriptive names. So if I say sure, I could just call this array A or something, or array list A or something like that, and that would make it a lot faster to write. But I might get confused later. And actually might end up making a mistake because I said A when I meant to say something else. So I wouldn't. So personally, I like to use more descriptive identifiers, but they don't really care. So yeah, let's move on to the next question there. Oh, okay. So there's actually more to this. So the following partially completed random letter chooser class is a subclass of random string chooser class. You will write the constructor for the random letter chooser class. I said that with an upward inflection, but that's unnecessary. Specifically about arrays, what don't you get about them? So basically, it extends random string chooser. Random letter chooser is a subclass of random string chooser. And we just have to write the constructor. And what this does is the code segment will print the 3 letters in cat in one of the possible orders because there are only 3 letters in the original string. So it's actually just going through letters now. Binary to hexadecimal was not part of the AP subset when I read it for this year, so I wouldn't worry about that. So you used to have to. It used to be on the test, but it actually wasn't part of the subset, and it wasn't part of the subset last year. So I think they're just doing away with it. No, I'm actually not. It's. I still teach it. I still teach it because I think it's useful to know, just in general, especially if you're continuing your studies in computer science. But it's not really a thing that you should need to know for the test. And if not, oh well, But it wasn't part of the AP subset, so I don't think that you should have to worry about it. Unless I'm way off, but I don't think I am. So so this one has a method called get single letters. So basically, it looks like what we can do is when we write the constructor, we just call get single letters on whatever string is passed. Oh, good lord. All right. So it's a random letter chooser. So public random letter. Make it obvious that these are not the same. So random letters chooser is passed a string str. And then, so it looks like all we really have to do is take, so for, we would call super, it looks like, and we would say something like, we would say super get single letters, and then I guess we would just say string. I think that's it. So basically all we're doing is, for this one, is now I'm getting sleepy. So the you're calling get single letters, which turns that string into an array of strings, and then the cool thing is what the initial class did that we already wrote is it takes a string or an array of strings and then does all this stuff for you. So all we actually need to do is do super. Super calls the parent class's constructor. So random letter chooser is a subclass of random string chooser. So we have access to all this stuff just through the use of super. So if we say super, and then we do get single letters first to just like make it into an array of strings, make str into an array of strings, and then we just call that. Let me check. It would usually say if we need to. Yes, you do. Now, actually, all it says is you must use get single letters appropriately to receive full credit. So you could theoretically just rewrite what you did in the parent class, and that would be fine. Like, you wouldn't get points off for it. But just make sure you read these notes, because it'll say that you are obligated to use the to use certain methods or class calls in your answer. So in this case, you have to use get single letters, which we did. So you actually don't have to know, or you don't have to use super, but all super is just like you're just calling the parent class. If you wanted to call get next, for example, you could say super dot. I'm not putting it in there because that's not the answer, but like super dot get next would just call the super class's get next function. Okay. Yes, you definitely need to know two-dimensional arrays. That's a pretty integral part of everything. And okay, so I'm going to answer some of these. I'll answer the easier ones first. Private or public is private and public have to do with accessibility. So there are 4 accessibility modifiers in Java. There's private, public, default, and protected. The ones you need to know about are private and public. So just forget I said the other 2. Private just means that only things within the class itself in which either that variable. Also, I actually messed up on random string chooser. I had to make that words remaining private. I would have gotten a half a point off for that, so shh, don't tell the graders. You have to know. So private means that random letter chooser, even though it's a subclass of random string chooser, does not have direct access to words remaining. So we couldn't just call words remaining in random letter chooser. If there was some sort of accessor method or mutator method, that would be fine. But yeah, we wouldn't be able to directly access it. A public method can be accessed by anybody or any class that is any ostensibly related to random string chooser. So that's really the difference between public and private. Public just means that it can be that variable or method can be accessed by anybody. Private means it can only be accessed by the class itself. That's all you need to know for that. So accessors and mutators are just typically public to begin with. So, for example, if we were going to write mutators and accessors here, we would say something like, public array list string get words remaining, and then that would just return words remaining. So this could be called because it's public. So we can call get words remaining. We just couldn't directly access the variable words remaining itself. And same thing for modifying it. As far as static goes, you shouldn't see static too much, but basically, so a static variable is going to be the same. I'll just do a quick one here, and then I'll talk about free responses. So if we had a class called student, like maybe we have like a private int age, we could also have a static variable called ArrayList student class list, something like that. And if we did that, or we can say something like this, I'll make it easy. Static int number of students in school. And we'll initially just set that, or yeah, we'll just do that. So if we did that, basically like if a student has a birthday, birthday is only going to affect the current student. But if we said something like add new student, and then give them like, pass a new student, and we said number of students in school plus plus, this increases that variable for every student object. Whereas birthday was only going to be, so if we called birthday, it would only increase the age of one student object. But if we had an add new student method that increased number of students in school, it would actually increase the number of students in school variable for every single person. So as far as like approaching the like approaching the free response questions, I mean, it's a good question because unfortunately the AP Computer Science exam ends up kind of being a reading comprehension exam a lot of the time, which is kind of dumb because it sort of penalizes people that are just naturally slower at reading, and those people might be very good coders and given enough time could do all this stuff perfectly, but because of the time constraint, they're penalized quite severely, in my opinion. So my recommendations to them are to skim through the problems. So like you initially just skim this. Like you don't want to like read every single word here because it's just going to take up too much time. Instead, just go right to the question and see what the question is, and then work backwards from there. Because usually this just has background data about what you're trying to do. So if you go to the question itself, read through the question entirely, see what you have to do, and then just go back to the other more, I'm not going to say filler information because it's not really filler, but just go back to that later. But just I would read the questions first. Also make sure that if you see something like, you must use get single letters appropriately to receive full credit, make sure that you are using those things. Even if you don't do it right the first time, you don't really have to worry about it. As far as the multiple choice goes, what I would say is just, if you see a problem that's really long and would require a lot of reading, I would actually just go back to it later. I would just go through and solve all the ones that are just like, here's a for loop, what does the for loop do, or something like that. Because those should be done pretty quickly, or the ones that are just like evaluating a Boolean expression. Those are pretty quick. The ones that have you read through a lot of code and like find the mistake in the code, each question is worth the same exact thing. So the easy question about Boolean expressions or like like a loop or something that's like counting is going to count the same for you as a really, really long question where it's asking you to like read through a bunch of tedious code. So what I would recommend is just do the shorter ones first, and if you see one that's like long and you feel your brain immediately start to melt a little bit, I would just skip that one and just go back to it.
So about it's about you have to get about a 75% to get a 5, and it's about like a 55 to a 60% to get a 4. It might be like 60% to get a 4, something like that. But you usually have to get about 75% of everything right to get a 5 on the exam. But it's very doable. Big O's don't exist on this test. So Big O used to be covered in the computer science AB exam, but you don't have to worry about algorithmic complexity or time complexity or anything like that on this exam. It's not covered at all. So don't worry about Big O's, quadratic time, linear time. I like that stuff, but it's not necessary on this, so don't worry about it. So as far as nested for loops go, so for nested for loops, my thing I like to do is I like to actually just make a chart of what I'm doing. So if I say something like, I actually did the sorting methods a little bit earlier. I said to basically just go over selection and insertion sort. So it's like, this is an example of the type of problem that you would see. And basically this is a selection sort, and what it would say, it would say something like value not given, expression not given, and then it's going to ask you to, it's going to give you some multiple choice like fill in the blanks. You're not going to see sorting on the free response at all. Like, you're not going to have to write your own sorting algorithm, fortunately, because that would be pretty difficult, really. So instead, it's on the multiple choice. It's usually about like 2 questions, usually near the end, and it's filling in the blanks. I talked about it a little bit earlier, so I don't want to talk about that much more. But I would just go over selection and insertion sort, and I would make sure that you could just like do a binary search, or at least like understand a binary search when you see one. But as far as going through for loops, comments mean nothing, so don't worry about that. So when you see for loops like this, a lot of people are just like, this is, I mean, it looks really horrible. So what I like to do is, and then maybe like it would just print out some or something like that. So maybe the question is, what is sum here? Iterators are not covered on the exam now. So with this one, the way I'd recommend going through it is actually making like sort of a T-chart and just keeping track of what A currently equals, and then what B currently equals, and then maybe like what sum currently equals. So it's not gonna work well on a computer, but I'll give you the idea of like what I'm talking about. That did not do what I expected it to. So basically what I like to do is I like to keep track of what the current values are. So for example, like the current value of A would be 0. And then we go into the inner for loop and we see that B is equal to A plus 1. So that's just going to be 1. In that case, so B is less than 5, so sum plus equals A times B, which is 0. So now sum is currently equal to 0. So basically I like to do stuff like this, and that helps me keep track of everything, because the AP is known for asking really just dumb questions that aren't really practical in like an industry setting, and they'll ask questions that are just complicated. So using this sort of chart will help you keep track of things. So if you have a nested for loop that's confusing you, I would just do something like that. So let me go through some of these questions. So recursion appears a little bit. So it's usually like 3 to 4. I'd say like it depends on the year. Honestly, it's between 3 to 5 questions. I'd say. There was one year where I heard there was a lot of recursion, but usually there's at least like 3. So it's usually like 3 to 5 questions you can expect on recursion, ranging from like easy sort of like tracing ones to ones that are a bit more complicated and like have to do with the recursive stack. Comments aren't needed at all. Recursion does not appear in the FRQ, no. So oh no, because sum should still be equal to 0 because a times b, which is 0 times 1 is 0. So no, recursion doesn't appear in FRQ. And yeah, like I agree with you that like the charts do take up a lot of time, but like it's if you're trying to solve the question and get the question right, a lot of times it can be just really beneficial to you, because if you're eyeballing it, it might just be a lot harder. Yeah. Anyway, that's probably as much as I want to do. But if anybody has any last minute questions, I can try to answer them. Yeah, I can show you binary search. Like this is binary search. So it's basically just it's the idea that a binary search is past 3 things. It's past a low, a high, and a num. So it's basically just like the low index, the high index, and then the target value that you're trying to find. So what you do is you find the midpoint. The midpoint. I think the stream is public, but I'll check and make sure. Yeah. So the midpoint is going to be low plus high divided by 2. So essentially you just want to go right in the middle. And you say if low is greater than high, you return -1, in which case you just want to, like, returning -1 just means that that element num, the target value, is not actually in the array. And then if what you're looking at is less than num, you basically go halfway, you take away that midpoint that you're currently on and everything before it, and then just go over backwards. Can I go over the basics of coding? Yeah, do it right. So our mid is greater than num. So in that case, the value that you're looking at is greater than the target value. And then you just return the mid if you're actually there, because that would basically just mean that your target value is equal to your mid value. So using an abstract class over an interface, I mean, they'll tell you on the test whether or not you're going to be using an abstract class or an interface on the problem. So it's not like you're going to have to like choose one or the other. And yeah, binary is recursive. Merge sort, probably not. Insertion sort, you should probably look at. So yeah, as far as interface versus abstract classes, that's honestly a question like for another day, because it has more to do with like programming conventions and like how you structure your code, but it really doesn't have much to do with the AP. It's like I would just say like just do them for the AP, and then like later when you're actually doing like more real coding, like you can actually like use them a bit more. Interfaces and abstract classes actually get used a lot in industry though, especially like there are some good books you can read on just like how to structure your code, but it's irrelevant to the AP, so I just want to go over that. So there are a few questions here. For two-dimensional arrays, like it's
so I've already done a few two-dimensional array stuff, but almost always the two-dimensional array questions look something like this, where you start with a row, you go through the rows, and you say while row is less than matrix.length, and then you start with the cols for the inner, and then while col is less than matrix 0.length. Yeah, so for truth tables would take a little bit too long for me to like really go over. But truth tables are actually something that you can find a lot online. So if you look for other videos or something, like I guarantee you'll find some good stuff about truth tables that's actually probably pretty like concise, probably more concise than I can even explain it. Yeah, so you can remove the features that you don't need for the insertion sort, and then. Yeah, you don't really need to know binary to hex. That's not part of the AP subset anymore. It used to be, but now it's not. So you should be fine. You should be fine if you don't remember how to convert hex to binary and things like that, binary to hex. So anyway, that's about as much as I want to do. So good luck tomorrow. Hope it helped, and have a good night.